SAQs కదా ఆయన. Good afternoon, students. I am Srinivasan, physics lecturer from my dear students. Good afternoon. I am Srinivasan, physics lecturer from Spark Academy. Yesterday we started first year physics short questions. We did 4 questions. Motion a plane we started and we did some questions. The same motion a plane we are going to do another question. Prove that other short question. Prove that trajectory of a projectile. Trajectory of a projectile. Trajectory of a projectile is a parabola. Is a parabola. Show that trajectory of projectile is a parabola. So what is, we are drawing diagram. This x-axis, y-axis, body thrown at an angle theta with the velocity u at an angle theta. This is starting point, this is the ending point, this is point of maximum height. I want to prove that path of the projectile is a parabola. U is the velocity of projection. U is resolved into components. Ux is equal to u cos theta. Uy is nothing but equal to u sin theta. This is called horizontal component. This is called vertical component. So there is acceleration only in y direction. Projectile will be under the influence of gravity everywhere. Projectile will be under the influence of gravity only. So we are having acceleration only in y direction. X direction acceleration is 0. So we'll write here projectile is under the influence of gravity. Projectile is under gravity. Projectile is under gravity. So acceleration in y direction will be there minus g, but x direction acceleration is 0. There is no direction, there is no acceleration x direction. Hence, horizontal component of velocity will remain constant. They are not getting acceleration, neither increasing nor decreasing. Hence, horizontal component of velocity cos theta remains constant. Now, starting point is friends, starting point is O there. Starting point is O. For example, you choose some other point C here. This is the point C. Here C has got x coordinate as well as y coordinate. What is this? If you draw perpendicular, this is nothing but x coordinate is nothing but equal to y coordinate. So after t seconds, starting point is O. After t seconds, let body is at C. Let the body is at C. What is happening with respect to time? X coordinate and y coordinate are changing. For the projectile, with respect to time, x coordinate and y coordinate are changing. So what is x coordinate? X coordinate, you have to calculate with the help of horizontal component of velocity. X coordinate is nothing but u cos theta into t after t seconds. There is no acceleration. Ut plus half at square you need not apply because x direction acceleration is 0. X direction is uniform. Motion is uniform. That's why u cos theta into t. Same y coordinate you want to calculate. To calculate y coordinate, this is y coordinate. You have take the component u sin theta. Initially, what is the vertical component of velocity u sin theta into t. S is equal to ut plus half at square, half at square, half gt square minus half g, because ay is minus g, minus half gt square. So this is the equation. X is equal to u cos theta into t. X is equal to u cos theta into t. Y is equal to u sin theta into minus u sin theta into t minus half dt square. X and y are variables. With respect to time, x will change, y will change. But I want to bring relation between x and y. I want to bring relation between x and y. How to do that? From the first equation, you eliminate t. Eliminate t. Eliminate t. Okay. So from equation, friends, the second page of derivation diagram is there in other page, you can verify. From equation 1, t is equal to x by u cos theta. T is equal to x by u cos theta. I am eliminating t. This is the equation number 3, you see. Substitute 3 in second equation. What is second equation? Y is equal to u sin theta into t. T means x by u cos theta minus half g x by u cos theta whole square. There, here u gets cancelled here. Sin theta by cos theta, tan theta will get x tan theta, sin theta by cos theta, tan theta minus half g x square by u square cos square theta. X tan theta minus half g x square by u square cos square theta. Here what are variables? Y and x are variables. For a given theta, tan theta is constant. For a given theta, tan theta is constant. Let it be. Let it is equal to a. I'm thinking this constant is equal to a. Similarly, in second term, g is constant, u cos theta is constant. So this is also one constant. Let it be b. So this is all our imagination. Tan theta is equal to a, g by 2 u square cos square theta is equal to b. Therefore, we'll write the equation y is equal to ax minus bx square. This is the equation for parabola. See, mathematics people know y is x square or x is y square or y is equal to ax minus bx square. This is the equation for parabola. Hence, you can say that part of the projectile or trajectory of the projectile is a parabola. We have seen the earlier, you see the page number 1 diagram, that is a parabolic shape only in the absence of aerations, perfect parabola. This is the proof. They are giving 20-25% this question they are giving. More than 50% they are giving parallelogram law of vectors. Then yesterday I did one problem also, modulus of a bar plus b bar, that is also 20% they are giving that question. So this is another question. So we are going to do next question in the motion plane, last question in the motion plane. Next question, student. One more question I am doing. These also they are giving less percentage only, but even then I am doing. Derived expressions for maximum height. Derived expressions for maximum height, u square sin square theta by 2g, comma, horizontal range, maximum height, horizontal range u square sin 2 theta by g. The letters theta is angle, u is velocity of projection. The letters will have the usual meaning. Letters will have the usual meaning means u is initial velocity, theta is angle of projection, g is acceleration due to gravity. So you have derived the expression for maximum height and range. So in the diagram, you have seen the diagram. You see this diagram. This is point of maximum height. This is the ending point. So this is called maximum height. Out of all the heights, this is maximum height. What is starting point to ending point? This is called range. This is theta. This is velocity of projection. Y-axis, x-axis. This is the diagram. In this diagram, first I am deriving maximum height. To derive maximum height. To derive maximum height. Expression for maximum height. Expression for maximum height. What is that? So your components, again you are taking components. What is vertical component? U sin theta. What is the horizontal component? U cos theta. Remember students, height is always calculated by u sin theta. Horizontal distance range is calculated by u cos theta. Remember in your mind, height is always calculated by the component u sin theta. Range is calculated by the component u cos theta. Expression for maximum height. So y direction is always under acceleration or retardation. So how to find out y coordinate? I am writing y coordinate to calculate always. You will write u sin theta into t. Not this one. Just 1 minute. H maximum we will apply. Of course, you can apply this one also, but simple equation apply. V square minus u square is equal to 2as. I am applying v square minus u square is equal to 2as. In this vertical component Vy, here vertical component will become 0 square. Here vertical component Vy will become 0. Here initially is u sin theta. Vy square minus uy square minus 2gs. You are writing. But at A what will happen? Vertical component will become 0. Vertical component will become 0. At A, vertical component will become 0. Uy is nothing but u sin theta whole square. And what is the s distance? This is nothing but s. S is equal to h maximum. S is nothing but h maximum. H or h maximum. Right? So 0 square you will get minus u square sin square theta is equal to minus 2g h maximum. Minus 2g h maximum. Minus minus gets cancelled. Ultimately, we are going to get maximum height expression. Implies that maximum height is nothing but u square sin square theta by 2g. Maximum height expression is u square sin square theta by 2. Once again, I am telling, this is the figure. I think figure you might have seen. A is the point of maximum height. O is starting point. So whatever height is there, from the x-axis to the point of maximum height, that is called maximum height. We are taking the equation v square minus u square is 2as. V vertical components. Whenever you are calculating height, vertical component, you are take vy square minus uy square 2 minus ds. S is distance traveled. Vy 0. Where it is 0? At the point of maximum height, Vy is 0. Minus u sin theta whole square 2 minus gh maximum. So after doing that, 0 square is minus u sin theta whole square. U square sin square theta is equal to minus 2gh maximum. Minus minus gets cancelled. Maximum height is equal to u square sin square theta by 2g. So one more derivation is there, range. One more derivation is there, range. What is the range here? Here, OB from the diagram, OB is called range. To calculate range, to derive range, to derive range. How to derive? Range is given by, you have used horizontal component of velocity into time of flight. Horizontal component, there is no acceleration. There is no acceleration. There is no acceleration. There is no acceleration. Okay, students, you see here. What is time of flight? What is time of flight? So in time of flight, you can take directly. You need not worry. Time of flight. It depends on vertical component. T is nothing but 2u sin theta by g. This first equation, this second equation. Substitute t value here. R is equal to u cos theta into t 2u sin theta by g. It implies that u into u square sin theta cos theta by g. What is 2 sin theta cos theta? U square 2 sin theta cos theta by g. From mathematics, you know 2 sin theta cos theta is sin 2 theta. R is nothing but equal to u square sin 2 theta. Sin square theta is different, sin 2 theta is different. So you know in mathematics, sin square theta is sin theta and sin theta. Sin 2 theta by g. Sin 2 theta by g. This is the expression for range. Range will become maximum for 45 degrees. Of course, in derivation, you need not tell about that. So for a given velocity, range will become maximum for 45 degrees. This is the expression for horizontal range. These are the derivations in motion A plane student. These are derivations in a motion A plane. Next, we are doing next chapter called laws of motion. Next, we are doing laws of motion. Laws of motion. Main questions in motion a plane I have covered. Now I am doing laws of motion. So in one more question, if you want to read, anybody having, for example, these questions are enough motion a plane. Define null vector, position vector, and unit vector. That one question is that definitions you learn, possibility is there. Define unit vector, null vector, and position vector. The definitions are very easy in mathematical point of view. So I am going to laws of motion. Laws of motion questions I am doing now. First question. Laws of motion, one short question will come. Laws of motion, one short question will come. What are the questions? Explain the advantages and disadvantages of friction. First question is laws of motion. Explain advantages and disadvantages of friction. Disadvantages of friction. You know, friction is a kind of force opposing the motion. What is friction? Oppose the motion. What are the advantages and disadvantages? First, we are writing answer advantages. Advantages. What is the advantage? We are able to walk. We are able to walk on a surface. Walk on a surface due to friction. Due to friction. Friction is not there, you will slip. Friction is not there, you will slip. You will push the ground backward and move forward. With your feet, you will push backward and move forward. We are able to walk on surface due to friction. This is very, very important advantage of friction. Then we are able to hold objects. You are able to hold objects like pen and all that, and able to write on board, and able to write in a book or board due to friction. Due to friction. Due to friction. Due to friction, we are able to hold the objects. We are able to write in a book due to friction. Third one is we are able to stop the vehicle by friction. Brakes are applied to stop the vehicle. So what is the advantage? Brakes are applied. Brakes are applied to stop the vehicle. Brakes are applied to stop the vehicle. To stop the vehicle. Even machines also, you can stop the machines by friction only. Brakes are applied to stop the vehicles where friction is used. Where friction between tires and ground. Where friction is used. So all advantages, mainly walking holding objects, writing. Brakes are applied to stop the vehicles. These are the advantages. These are the advantages. We are telling about disadvantages now. Disadvantages. Disadvantages is also there. Friction causes heat and power losses. Friction causes heat and power losses. Heat and power losses. What will happen whenever you are using friction? Due to that, heat is generated. Complete energy you are not able to use because you are running a wheel with the help of belt. But there is a friction is there. Because of friction between the metal and that belt, it causes heat and power losses. Due to wear and tear of the tire. Due to wear and tear. Wear and tear means rupture of the tire. Wear and tear of the tires or surfaces power heat losses are there. Heat losses are there. Whenever you are applying brake also, heat is generated. These are the disadvantages. This is one 4 marks question. Very, very important question. You can easily write generally, but you study and write. So this is the easy question we are getting in the examination number of times. More than 30% is there. Now next question. Next question is, mention the methods to reduce friction. Mention the methods. When friction is there, you have to reduce. Mention the methods to minimize friction. Mention the methods to minimize or reduce. Minimize means reduce. Minimize friction. Mention the methods to minimize friction. Here one thing is there. If you cannot write, you can keep side headings. With that you can get more than 2 marks. But every heading if you apply, you will get 4 marks. Mention the methods to minimize friction. First is called polishing. First is called polishing. Polishing. By polishing the surface, it becomes smooth. It becomes smooth and friction reduces. Friction reduces because intermolecular forces will become less. By using ball bearings, in the machines, by using ball bearings in the machine or cycle or anything, in the machine, rolling friction will be less than sliding friction. Rolling friction is less than sliding friction. That's why they use ball bearings than sliding friction. This is called ball bearings. Then next thing is using lubricants. Rusted is there. Using lubricants. Lubricants means oil. So any vehicle is rusted, what will do? Will apply grease or oil. By using lubricants like oil or grease, intermolecular forces decreases. Intermolecular forces decreases. Friction decreases. This is lubricants. Lastly, streamlining. Last one is streamlining. What is streamlining? Aeroplanes and automobiles Aeroplanes and automobiles are streamlined in their shape. They can't prepare aeroplanes as they like, or automobiles. Aeroplanes and automobiles are shaped such a way, such a way, such a way to reduce the friction due to air. Front part will be front part reduce the friction, due to air. 1 minute. Aeroplanes and automobiles are shaped in such a way such that reduce the friction due to air. What? నేనేం చేయలేను సార్ ఎందుకని బాగా ఏంటి నా రైటింగ్ ఇంతే ఇంకేంది అర్థం మళ్ళీ ముందని చెప్పాలి ఒకసారి ఈ క్వశ్చనా వేరే క్వశ్చనా students, what is the writing you won't understand? You see, everything you want, it is difficult to get, student. Adjust the writing. Different persons will write in different way, but I will try my level best. Polishing. By polishing the surface, it becomes smooth. Here, this is there here. It becomes smooth. It becomes smooth. So, by polishing the surface, it becomes smooth. Wherever you are not understanding, it becomes smooth. It becomes smooth. It becomes smooth, and friction reduces. By using ball bearings, in the machine, rolling friction is less than limiting friction. Sorry, rolling friction is less. This is less word, not clear. I'm writing here. Rolling friction is less than sliding friction. Rolling friction is less than SLIDING, sliding friction. Using lubricants. So using lubricants, next point by point. This is all theory. By using lubricants like, so this is by using lubricants like oil or grease. That side it is there. Oil or grease. I'm writing here again. That side it is there. So I'll just move this side. Move other. Oil or grease. ఇదేంటండి ఎక్కడ పోయింది రేపు ఇంత కాంప్లికేట్ ఉంది ఏంటి అసలు మామూలుగా డీటెయిల్ బోర్డు మీరు రాసేవాడిని అక్కడ ఆఫీస్ దగ్గర ఇంత కాంప్లికేట్ ఏం లేదు వీఆర్ ఏబుల్ టు వర్క్ అయిపోయింది కదా బ్రేక్స్ ఆర్ అప్లైడ్ టు స్టాప్ ద వెహికల్ వేర్ ఫ్రిక్షన్ ఇస్ యూజ్ డిసడ్వాంటేజ్ యూఆర్ టెల్లింగ్ రైట్ ఇలా అయిపోయినట్టే మనం 100 రోజులు రావాల్సి వస్తుంది ఎగ్జామ్ డిసడ్వాంటేజెస్ friction causes heat and power losses due to wear and tear losses surface heat and tear. But next point ekkadandi 3 point leze aslu due to wear and tear surface heat losses are there. Next point ekkadandi aslu by using lubricants and rasa kadandi ikkada undi kada using ball bearings reducing friction అదే కదా అడుగుతున్నారు వాళ్ళు అడిగింది ఇది కదండి అడ్వాంటేజ్ డిసడ్వాంటేజ్ అడగట్లే యూజింగ్ ఇది అడుగుతున్నాడు ఇంతకుముందు అడగలే కదా బై యూజింగ్ లూబ్రికెంట్స్ ఆయిల్ ఆర్ గ్రీస్ intermolecular forces like lubricants like oil or grease, intermolecular forces decrease, friction decreases. Aeroplanes and automobiles are shaped such a way to reduce the friction due to air. This is one question. Next question onwards we'll see. Please consider writing. Any further problem is there, please tell me. Further problem is there, next time writing problem is there, theory problem is there, you tell me. State the loss of rolling friction I'll write neatly whether you are able to respond or not. All of you see, my dear student, please you have to adjust writing. State the laws of rolling friction. Rolling friction. You know, car wheels and all that circular, they are doing. So that the laws of rolling friction. This is very, very important question. All these three today I am telling you is very, very important. Advantage, disadvantage of friction. That is one question. You should not confuse the answers, students. One method to reduce friction, we told, that is theory only. State the laws of rolling friction. So we are writing one by one laws of rolling friction. When a wheel is rolling, student, when a wheel is rolling on a surface, this wheel is rolling, it presses the contact here. It makes deformation. This is a wheel. Radius is there for this. Radius is there. So he says friction. Whenever it's moving forward, the center of mass moving forward, friction acts like this. Friction acts like this. Friction. So what are the laws of rolling friction? What are the laws of rolling friction? Rolling friction is directly proportional to normal reaction. First one, normal reaction acts like this. This is normal reaction. Rolling, I'll write slowly. Rolling friction is directly proportional to normal reaction. Is directly proportional to normal reaction. Normal reaction N. The first law. Rolling friction is directly proportional to normal reaction. Friction means F. Rolling friction, normal reaction. Second one is rolling friction is inversely proportional to radius. Rolling friction is inversely proportional to radius. Rolling friction is FR del, right? Rolling friction is inversely proportional to radius. Rolling friction is inversely proportional to radius. Inversely proportional to radius. Radius R. That means friction, rolling friction is inversely proportional to radius. Less the radius, more the friction. More the radius, large wheel means less friction will be there. Small wheel means more friction will be there. Small radius. This is second point explanation. Third point. Page marchala. Here, third, I am writing rolling friction is nothing but mu r into n. Rolling friction is nothing but mu r into n, where mu r is coefficient of rolling friction. Mu r is nothing but coefficient of rolling friction. So Fr is given by the formula mu r into n. So this is the third law. So three laws actually, right? It depends on radius actually mainly, because whenever wheel is rolling, it deforms the surface actually. What is happening is, whenever a wheel is rolling, wheel tire lower part will get deformed, road also get deformed. Due to this, friction is created and the wheel will roll from one point to other point, it will change. Now point of contact is P, of some time some other point will come to point of contact. First P is coming in contact, next P1 is coming into contact. This is called loss of rolling friction, which is very, very important for you. These three are only mainly important. I am telling lastly for formality, why pulling is easier than pushing. Why pulling is easier than pushing. Why pulling is easier than pushing? Why pulling a lawn roller is easier than pushing? This is 15-20% they are asking. Remaining are 30 to 40% they are asking advantage, disadvantages, methods of reducing friction, loss of rolling friction. These three only, if we verify from 1920 onwards to 24 papers, 4 years papers verify what are the questions coming from this loss of motion, you understand. Why pulling is easier than pushing? So I am writing diagram here. First pulling diagram I will keep. So this is only 10%, 15% they are asking. There is a roller is there. This is the roller. I'm applying the force at an angle theta, pulling. This is called pulling. But an angle theta, I'm applying. So this is F cos theta. This is normal reaction. So F is resolved into components. One is F cos theta, another is F sin theta. So you say this is not understandable. I'll write clearly F cos theta, F sin theta, weight will act like this. Weight always acts because this is having mass M, weight will act downward. This is called pulling. So friction will act this side. Friction will act this side. So what is normal reaction formula here? I'm writing N plus F sin theta will be equal to mg will become. What is normal reaction formula in case of pulling? N plus F sin theta is equal to mg. N is equal to mg minus F sin theta. N is equal to mg minus F sin theta. So if you take limiting friction or kinetic friction, what will happen? Static friction mu s n it will become. So normal reaction is getting decreased here. Okay, students? I'm bringing down. Why pulling is rather than pushing? It's chill. Man, chiన్న చేయలేము సార్ ఇది చిన్న చేయొచ్చు కదా నేను కంపేర్ చేయొచ్చు బిడ్డ అక్కడ చేసేవాళ్ళమే ఇది రైట్ here n is equal to f sin theta plus mg. So I am writing once again this step. Normal reaction is nothing but equal to mg minus F sin theta. Normal reaction is decreasing here. Next I am drawing pushing diagram. I am pushing this by applying. ఇట్లా మూవ్ అయిపోతుంది ఎందుకంటే బోర్డు ఎందుకు మూవ్ అవుతుంది అది కాదు నేను అనేది బోర్డు ఎందుకు మూవ్ అవుతుంది అట్లా నేను మామూలుగా ఇది అచ్చేయట్లేదే బోర్డు టగరం జారిపోతుంది ఇది తలకాయ నొప్పుంది నేను అసలు ఇంత అవస్థ ఇప్పుడు పడలేదు ఈ బోర్డు కూడా అవస్థ పడుతున్నాను నేను లేకపోతే ఏం లేదు దారుణంగా మూవ్ అయిపోతాయి మనం ఏం చేస్తాం ఒకసారి ఆ హ్యాండ్కి వెళ్ళాలంటే చాలా టైం పడుతుంది సో ఇంకా ఐఎమ్ టీచింగ్ స్టూడెంట్స్ తెలిసి సార్ని అడుగుతాను ఏంటి ప్రాబ్లం బాగాలే ఈ ప్రాబ్లం ఎవ్రీ టైం మూవ్ అయితే ఎట్లాగా వైట్ బోర్డ్ మీద రాసినప్పుడు ఈ ప్రాబ్లం ఉండదు కదా ఎంజీ సార్ని అడుగుతాం ఒకసారి ఎఫ్ సైన్ థీటా స్టూడెంట్స్ ఎనీహౌ ప్లీజ్ సీ టు ఇట్ స్టూడెంట్స్ it is not related to you pushing. No, it is pushing. This is called pushing diagram. This is not coming much students, but don't worry. But compulsory, you have to keep diagram pushing. Pushing means downwards. Pulling means upward. Here, normal reaction formula. What will happen in this case? Normal reaction is nothing but mg plus f sin theta. Here, in case of pulling, normal reaction is how much? Mg plus f sin theta. In case of pushing, mg minus f sin theta. Therefore, సార్ వాళ్ళ దగ్గర రాత వాళ్ళకి బోర్డు మీద రాస్తున్నప్పుడు వాళ్ళ ల్యాప్టాప్లో చూసినప్పుడు తీసేరా సార్ తీసేస్తాను ఇవే ప్రాబ్లమ్స్ ఆన్లైన్ క్లాసులు పిల్లల్ని మనం చాలా జాగ్రత్త చూసుకోవాలి అంటే వాళ్ళకి రైటింగ్ అన్నారు సాల్వ్ చేసుకోవాలి ఏదో ఒకటి మళ్ళీ